Okay, so we're going to be doing number 39, which is a blue problem. And what 39 gives you is a rod of length 0.3 meters. They say x equals 0.3 meters here, and then x equals 0 here. They also give you lambda, which is linear density of that rod. They give it to you in grams, but I put it into kilograms for you. Now, part A asks you to find the mass of the rod, and part B asks you to find how far the center of mass is from one end of the rod. So we'll start with part A. Now we know that mass equals linear density times length, and because that is true, a very small mass equals an infinitely small length. But in this problem we're going to use dx because our lengths are defined by x. And so what we have is dm equals lambda dx. They give us lambda in the problem, so we're just going to go ahead and plug in this expression for lambda. So dm equals 0.050 plus 0.020x dx. Alright, and what we have to do to find the mass is integrate. So m equals integral this 0.050 plus 0.20. So what the mass will be is the linear density times each of this infinitely small lengths that we have, which is dx, and so those small, infinitely small lengths will be from 0 to 0.300 meters. So those are our limits of integration. Okay, so we'll just go ahead and integrate this. X plus. So we're integrating from 0 to 0.3. So to find our answer, we're going to have to plug in 0.3 into this expression and subtract whatever we get from plugging into 0. And I'll go ahead and skip the algebra step for you to make this process quicker. And what you should get from this is 0.0159 kilograms. Now that's our answer to part A. That is the mass of the rod. So over here I'm just going to write mass equals 0.0159 kilograms because we're going to have to use that in part B. Now part B asks you to find how far the center of mass is from one end of the rod. And to find that, we're going to have to use a formula that was given to us in lecture. So I'm just going to take this formula straight from lecture. xcm equals 1 over m times integral x d m. Yeah, that is the formula. Okay, so as we know, dm equals lambda dx. So we're going to go ahead and plug lambda dx in for dm. So we are left with this. And we have lambda here, so once again we're going to have to plug in lambda. I'm going to go ahead and plug in what they give us for lambda and then multiply it by x. So what we're left is 1 over m times the integral of 0.050 x plus 0.020 x squared, quantity dx. And our x's, we're going to integrate from 0 to 0.30 again, because 0.300, because that is our length of the rod. And if you go ahead and integrate that, we will get 1 over m times 0.025 x squared plus 0.020 over 3 times x to the third from 0 to 0.300. Now all we have to do left is plug in 0.3 for our x and then subtract whatever we get from plugging in 0, and then divide the whole thing by m, which we found in part A, 0.0159. Basically, it's 0.025 times 0.3. I'm leaving out units here, which is really bad, but it's kind of confusing when I put in units. So, anyways, 0.3 squared plus 0.020 over 3 times 0.3 cubed, all over 0.0159 kilograms, and then this up here is going to be, I think, kilograms over something like that. No. Whatever. Your answer will be in meters, and then our answer will be 0.153 meters, which means that our center of mass is 0.153 meters away from the left end of the rod, which is x equals 0. So it'll be like around here.